In this video, we're going to take a look at the VANTIQ application platform for building event-driven applications. And the VANTIQ application platform is a full-featured platform that not only allows you to build these event-based applications, but it also allows you to build complex interactions or collaborations between people, streaming sources, and systems. So when you first log into VANTIQ, you're brought to the introduction screen. And this is a really helpful screen. Of course, you've got things like our developer documentation, you've got some tutorials, and you've got some introductory concepts that talk about all of the components that are in the VANTIQ system. And I'm going to walk you through just a couple of them really quickly. So for example, sources are VANTIQ's way of interacting with third-party applications. For example, I've got a source set up for SMS. I've got a source set up for the Google API. And you define a source by setting things like its server URI, you can set access tokens, and of course you can set things like path, query parameters, content type, and a whole host of other things in order to sort of create this REST addressable interface to another system. Now, procedures are ways of sort of creating little functions in the VANTIQ domain-specific language. And so, for example, here you see I have a procedure called Google Reverse Geocode. And if I open up, I've got this procedure called Google Reverse Geocode. It takes in a single argument called location, and that location is a type of GeoJSON. And what this does, in just a couple lines of code, is it creates two variables from the location object, the longitude and latitude. It creates a path variable, which is information that we're going to put onto the end of the server URI that you saw from our Google source. And then one last variable called result. And one of the really nice things or cool things about the way the VANTIQ system works is that interacting with third-party sources looks an awful lot like a SQL statement. Here you can see it says select from source Google API with the path. And what it's going to return is a bunch of Google information of which I'll parse out the formatted address. So let's go ahead and see that in practice. I'll go ahead and go to procedures. I'll run Google Reverse Geocode. I'll set my location or my GeoJSON object to a point. The longitude will be -72. The latitude will be 42. And then when I execute this procedure, it immediately comes back from the Google API with Norwich, Worcester Turnpike, Woodstock, Connecticut. Now, one of the really cool things about VANTIQ is you automatically get this as a REST addressable service. In fact, all the sources and all of the procedures and the types and so forth are immediately REST addressable inside of the system. Whatever you create has a REST endpoint. It's kind of like getting AWS Lambda and API Gateway. So, for example, I'm going to open up a REST client here. And in my REST client, you can see I also have Google Reverse Geocode, and it's pathed out to dev.vantic.com, API v1, resources, procedures, and Google Reverse Geocode. Pass in my bearer token, the argument that it's expecting, so it's a location, and it's a GeoJSON type, so type, point, coordinates, and then -72, and 42, similar, almost a little bit off from my original location. I'll go ahead and hit send there, and you can see it comes back with Brimfield Road, Massachusetts. Let's go ahead and just change it off by 1 degree here. And moving it over, moves to 246 Lakeview Street, Sharon, Massachusetts. So you can see we instantaneously get REST addressable endpoints to anything that we create inside of VANTIQ. But let's move on. The next thing we'll take a look at is rules. Rules in VANTIQ are how we deal with the streams of events that come into the platform. So a rule always starts with a when clause. So when an insert occurs on one of our types. So when an insert occurs on customers, when an insert occurs on, the transformer HUD or something of that nature. When an update occurs, when a delete occurs on any of those things. We can also say when a message arrives from one of our sources. So if we had an AMQP source or an MQTT source, we could do that as well. We can even say when a publish occurs on an internal topic to this particular VANTIQ namespace. Things like the crew logins, service new, which is what we use to identify situations of interest, at least in this demonstration application, and then some of the other things that you see here. So we're going to take a look at this application. One last thing we'll take a look at very quickly are these things called types. Types in the system are a sort of persistent way of storing the data. You can think of it like a table inside of a database, but they're a lot easier to work with and they're a lot more flexible. But here you can see I've got a type called the transformer HUD, the heads-up display. I've assigned a natural key and some indexes on it, and then I've assigned a bunch of properties, things like the coil temperature as a real or the current as a real, the location, the installation date, and a number of things that I might want to display or that I might want to interact with. Keeping in mind that what event-driven systems do is they allow us to take in a stream of data. They allow us to orient around that stream of data, enrich it with context, and then take action and collaborate with other systems and humans. And that's what we're going to see inside the demonstration today. So let's go ahead and get to the demonstration. Let me just first describe the application itself. The application that we're going to be working with is focused on a utilities demonstration or an energy demonstration. And one of the things that we've seen is that there's a huge hole, a black hole, if you will, with transformers, the kind of transformers that you'd see on the street, relative to the current infrastructure. And that is that the transformers themselves are a giant black hole because no data comes from them. We don't know what's happening. There can be things like energy theft going on in the transformer. You might be able to get it from a substation, but you don't necessarily know which transformer. Also, a lot of these transformers are nearing the end of their life. And of course, when a transformer goes, it causes, or a number of transformers go, it can cause blackouts. And the cost of blackouts and down data is really astronomical. It's a problem that ranges in the billion-dollar range. Of course, replacing all of these transformers is also a billion-dollar problem if you were to try and replace them all at once. So you have to be smart about which ones you replace. And the question, of course, is which ones to replace first. And what we can do with an event-driven system like the VANTIQ platform is we can take streams of data from the transformers and we can predict failure on them by adding devices to these that are much cheaper than the cost of a brand new smart transformer. And we can sort of upgrade or give a 21st century upgrade to older, dumber transformers, sort of give them a smartness, if you will, give them a set of sensor readings, and then we can use the platform to iterate over that to do things like predict failure, to schedule maintenance, and therefore we have scheduled downtime versus unscheduled interruption of the service itself. And of course, all of these things increase customer satisfaction and of course control the rate and cost of replacing transformers by using a device like these. But of course, we need to be able to interact with the event streams that come from them, and that is what this demonstration application does. So the first thing I want to show you is how we built this application. In the VANTIQ platform, we have this thing called projects. And I've opened up a project here called the Transformer Service. And what this does is it shows us, one, a project resource graph. This resource graph shows us all of the rules, procedures, sources, topics, and anything else that makes up this project so we can see it at a glance. And so a couple of things that I can see here, if I just read this quickly, I can see that there's a topic called Transformer Smart Reading. That's a topic of information that comes into the system. It encounters a rule called the Smart Transformer Reading, and then it inserts some data into a transformer series type, and then also into the transformer HUD. And then based on various things that happen, it might open up a collaboration. Well, let's first take a look at what this rule does. The rule is written in our domain-specific language, and you can see there's only about 13, actually less than 13 lines of code here, probably about 10 lines. And as I mentioned before, rules start with a publish statement. So when a publish occurs on transformer reading as smart, then insert into a special type called a special time series type called the transformer series. I'll put in the ID of the transformer and the timestamp, the current and the voltage, and what I'm going to calculate from that. This time series type automatically calculates the rise. And you can do any aggregate function. You could do an average, you could do a min, you could do a max. In this particular case, I'm calculating the rise of both the current and the voltage. And then I immediately select it back. I select from the series transformer series that I just inserted into as a variable called reading, where the transformer ID matches the ID of the transformer that came in on our topic. Then I add it onto this object here called smart, and then I update the whole HUD so that I get this enriched version of the data. Now, all rules don't need to be written by hand. We can also write a number of these rules in a very visual way, which makes it much more of a configuration than it is a customization. So let's show an example of that. And so what we'll take a look at now is a visual rule that actually identifies the situation of interest. This was how we brought the stream of data into the platform. What about identifying the problems in the transformers themselves? So let's come over here to our other tab, and I'm going to come over to visual rules, and you can see I have three. I've got a rule for fluctuating current, I've got a rule for high coil and oil temperatures, and I've got a rule for zero voltage. When I open one of these up, underneath the covers, it's actually writing the same logic in the hand-edited rule from a moment ago. But again, this gives us a visual way, sort of almost a spreadsheet-like way of dealing with this. So here you can see it says when an insert occurs on the transformer HUD where the voltage equals 0 and the repair mode is set to false, then I want to call a procedure which publishes onto a topic the entire object of what we just inserted into, and also puts in a reason, which is 0 voltage, which was the reason that this rule was triggered. Let's take a look at one more. So I'll go into high oil and coil temperatures. So this one basically says when the transformer type is a smart transformer, when its coil temperature is greater than 135 and less than 150, and the oil temp is greater than 140 but less than 156, then we'll also call that procedure service new, and we'll set the reason to oil and coil over 90% max safe value. This is kind of like a mini prediction, because if this stays over 90% max safe for a period of time, that is actually indicative of an impending failure that might come within, a couple days or even a few weeks. And so we can use this to schedule a crew to go ahead and replace that one particular object, as opposed to trying to replace all of them at once. And then another rule row beneath it, which basically says if it's greater than 150 or greater than 156 in the oil temperature, then it's over 100% of its max safe value, and that will cause a series of different conditions. But what these visual rules have done is they've simply identified that a situation of interest has occurred. And so that's where these collaborations come in. A collaboration then is all of the individual steps that represent, or all of the individual interactions that represent how to triage the situation of interest that we just identified. So it always starts with an initiate action. And this initiate action basically says, when a publish occurs on that topic, service new. And we know that what we put onto that service new topic was all the information from the transformer, and we also put in the reason. And so then a couple of things happen, and I'll only walk through one or two of these, but let's take a look. The first thing that happens over here on the left, this is an event-driven system, so this entire tree is always active all the time. The first thing that occurs is we come to our escalate issue. And you notice each one of these blue boxes is a different type of activity. And so here we can see that this is an escalation activity, whereas over here, this find crews is a recommendation activities. Well, what activities are is they encapsulate the code for very common operations. So for instance, an escalation activity is what would occur if something doesn't occur in a certain amount of time. So in other words, when the situation of interest occurs, what I'm asking the system to do in this particular case is to wait. And it has a single configuration parameter, which is the time. In this particular case, I'm asking it to wait 30 seconds before continuing. Once the escalation is triggered, then a couple of things happen. One is I execute some custom code called address near transformer. This is a configuration that runs that Google reverse geocode procedure that we asked for. So basically we're saying when it escalates, then I want to get the closest address because I want to feed that address to our crew when we find our crew. Again, this one's a recommendation activity, so this is an out-of-the-box procedure. And you can use recommendations for anything. You could use it to find, for example, the correct box to ship a particular item in. In this particular case, we're using the crews type, which is a list of all of our crews. We're asking it to recommend a maximum of 1. So we want the closest crew in this particular case. And the recommendation procedure that we would use is this nearby recommendations. In other words, we're asking the system to find for us the closest crew relative to the telephone pole that houses our particular transformer. And then once it does that, we have these little services that can kick off, such as updating the collaboration HUD. This is just a little one-liner which updates a dashboard for us. In fact, if you want to see that, here's the update collaboration HUD, which literally has about 4 lines in it. If there is a location, then update the HUD, and if there isn't, then delete it from the HUD. Once it notifies the crews, it sends down a mobile response. And VANTIQ also has a mobile application developer to handle this. So you'll see in this particular case, here is the transformer notification, which simply has an accept or reject button on it. You'll see that momentarily inside the demonstration. And we also have a crew instruction, and you'll also see this, which has a little bit more information, such as the transformer's ID, its type, and the location that we got back from the Google reverse geocode that we did from before. And so what happens in our collaboration is once we've notified the crew, if the crew member hits that accept button, then the crew is then assigned. And once the crew is assigned, we start doing two things. One is we send down the crew instruction. We send down this form, which has all of the details about where they're going to go. And then we also start tracking their location on the planet. And once we start doing location tracking, every time their phone sends an update, we go ahead once again and update the collaboration HUD with this procedure here. This updates our dashboard. And then as we arrive at the scene, we'll update the collaboration HUD with some additional information, such as, that the crew has arrived. We'll also set the repair mode of the transformer to true, so that other signals coming through won't cause other collaborations or other situations while the transformer's in repair mode. And then finally, we'll also send a text message to the tech once they've arrived. So you've pretty much seen, and most of these things don't have any code associated with them, especially all these blue ones, because these are the activity patterns that come out of the box that help you rapidly put together these applications without any code. So you can see, for example, in assign crew, all I provide is the role name, which I called truck, and then it happens to be a collaborator. And for the runtime parameters, it's coming back from the mobile device, the username from the event stream that came from the mobile device's submit button. So you see very little code to create this very complex application. You've seen almost all of it. Maybe you're missing 20 lines or 30 lines of code visually here. If I clicked on all of these, you'd get a chance to see them all. But this is fundamentally the whole application. So now for the fun part, let's actually see it work. So I'll come back to our main screen. And what I'm going to do here is I'm going to log into our application. So I'm going to bring up the mobile phone here. And I'm going to click on log in. And what you'll see here on the screen when I log in is you'll see in just a moment the crew contact, me, Brett Rudenstein, logged in to true. And you also saw the map update. You see my location on the planet somewhere here in Massachusetts. So let's also take a look at some of the transformers that we're monitoring. And I'll just take a look at the transformers that are in my particular area. So I'm going to come over here to the monitoring tab. And in the monitoring tab, you can see that I am seeing a stream of events. So you'll see these change every couple of seconds, because every 5 seconds or so, we're getting each one of these transformers to send us in their data. And they're sent in via REST onto one of our internal topics. So that's that when a publish occurs on, transformer reading. So here we see the voltage from the transformers. We see the current from each of the transformers. For the few number of transformers that we have that are actually newer transformers that actually can provide the oil and coil temperatures internally to the transformers, we're seeing those here as well. We're also seeing our special time series, the rise of the current of each of those transformers, all very nicely within nominal value. And then our collaboration heads-up display, which is not showing us anything because there are no situations of interest until something happens. And so what will happen now is we're going to go ahead and drop the voltage down to 0 on one of our transformers. If you remember, I'll come back over here for a moment, we have a visual rule called 0 voltage that says when the voltage drops to 0 and it's not inside of repair mode, then that will be the entrance to our situation of interest, and it will go ahead and it will start this collaboration. But one of the things that you'll see here is if it's 0 voltage, then it calls this out-of-the-box procedure called trigger escalation. So if it drops to 0, it's a problem. It skips this escalation and continues right with the rest of the tree. So we'll go ahead and we'll see that now. So I'm going to send a signal here to one of our demonstration transformers to tell it to stop sending voltage, or to send 0 voltage, I should say. And we'll see a couple of things here as this occurs. So on the mobile phone here, you see that I got dispatch request. Transformer voltage is 0. You also see in the collaboration HUD there it says 0 voltage, locating service crew, waiting for a response. And we also saw the time series data fluctuate here as well. So on the mobile device, I'll go ahead and I'll open up the mobile. And we see that we got a dispatch request. And so what I'll do is I'll open up the dispatch request. And of course, you see the first form that we developed in the real-time collaboration editor. So here is the transformer notification, the accept and reject buttons that we saw from before. When our operative or our crew member accepts this, I'll go ahead and I'll hit accept. When they accept it, you see that I instantly got back a service notice. And the collaboration HUD will change instead from locating service crew, waiting for response, to it now says that the crew is en route. Now, it's also doing that mobile location tracking as well. As soon as our crew arrives at the location, then it will also send us a message. So there's our Twilio message. It says, you have arrived. And so you've seen the other part of the workflow engage because I happen to already be at the location. It sent me my arrival notice. Then, of course, as the technician, I'll open it up and I see all the details, information, and so forth. And then I can select a repair value. Now, before I do that, of course, if I were to repair the device now, that wouldn't actually fix the device because the device is still emitting 0 voltage. So what I'm going to do here is we're going to put the voltage back to normal. And with the voltage back to normal, you saw on the screen that the voltage jumped back up. We also see a quick rise in the transformer time series. That might even count for fluctuating current because it's such a sharp curve. But the reason that it did not trigger another collaboration is because the transformer is in repair mode. So the last thing that our technician has to do is come over to the label. He says how he replaced it. He fixed the line. Maybe the line was simply down. He says the line was repaired. And he goes ahead and submits it. And once the submission is complete, it will go ahead and disappear from the collaboration HUD because we have closed out that particular problem. So there you've seen sort of a end-to-end demonstration of the monitoring of various transformers, both smart transformers and some transformers that have been made smart with an add-on device, taking that data into the VANTIQ platform, enriching that data, and then providing meaningful collaborations between humans and other systems in which to triage that particular situation. I'll show you one last thing that's of interest here. VANTIQ also has a client application builder. So we've looked at a mobile application. There's also a development environment for building clients. And so, for example, let's say we needed to do something like add a transformer into the system. So we have a development interface in which we can drag and drop various form properties. So I created a data object for our latitude, our longitude, and all of the objects from our transformer HUD, and then simply drop them onto the screen. In fact, you can do that very quickly if I add a new page by coming over here to data objects, adding a typed object based on something, and then say add it to the form. And so here you can see we've added all of the information to the form. Now, I didn't need this for my original page, so let's go back to the start page here in this particular case. Here's what I got left with. I also added a table that will show all the transformers, the last 5 transformers, and a map that will show the last version of that. And then I've added on a submit button and a reset form. So we can actually create these clients and provide sort of rich experiences for end users, not only through mobile applications, but also through a web front end. And we'll just go ahead and put this in run mode here for a moment here, and we'll just add a transformer to the system. So we'll call this the T_12345. That's a good name. The installation date for this transformer is today. The transformer type will be one of the new smart transformers. It has a maximum coil temperature of 233 and a maximum oil of 223, and its latitude is minus 72, and or its longitude is minus 72, and its latitude is 42. And when I go ahead and I submit this, you see it says transformer 12345 submitted. You see it has appeared on the screen, and you also see it has appeared in our dashboard. So the client builder is a way to provide a rich experience to end users as well in this event-driven platform. I hope this gives you a pretty good sense of the VANTIQ platform for building event-driven applications. Thanks for watching.